尊敬的各位来宾，大家好。
Dear guests, welcome to the Top 10 Trends of Site Power Launch 2024. Against the background of carbon neutrality, the site power industry is experiencing innovations of green technologies. While accelerating the green development of operators and tower vendors, this industry faces more opportunities and challenges. To gain insights into industry trends and achieve rapid development, now we would like to invite Mr. Li Shaolong, President of Huawei Site Power Domain, to introduce the top 10 trends in site power in 2024.
大家好，我是赞点能源领域总裁李少龙。
Dear guests, I'm Li Shaolong of the Site Power Domain. I'm glad to share with you the top 10 trends in the site power domain in 2024. We know that energy has developed rapidly in recent years, especially low carbonization on the power generation side and electrification of power consumption. At the same time, the energy crisis results in higher energy prices. This trend has affected operator size and caused many changes in the site power domain. Against this background, operators have gradually moved from energy consumers to prosumers. It is a very obvious trend. Why do operators move from energy consumers to producers? There are several main reasons. The first is the sharp increase in power consumption. We know that the past few years, 5G developed rapidly. The power consumption of 5G devices is higher than that of 2G to 4G devices. As the number of 5G sites increases, the power consumption and carbon emission of operator sites increase. Therefore, operators are facing great pressure. Second, the energy crisis has led to higher energy prices. For example, in the past few years, operators' electricity bills in Europe have increased by 30%, and some operators have even increased by 300%. Over the past few years, more governments have introduced carbon peak and neutrality policies. Many leading operators have released their own carbon peak and neutrality policies. The above three factors drive the transformation of operators from energy consumers to prosumers. As a consumer, power for ICT is the main theme. Power is used to supply to traditional operator equipment. The main objective are efficient sites and efficient equipment rooms. For example, power is supplied to ICT equipment in wireless sites and equipment rooms. The other aspect is ICT for power. Operators use ICT technologies to enable various industries. For example, PV deployment to supply power to surrounding areas. In addition, operators use site energy storage to participate in power services and earn greater benefits. Operators in Africa and Middle East countries use power supply devices at sites to supply power to residents in the nearby. These are all cases and scenarios of operators' energy transformation. As we have just mentioned, an important change for operators as energy producers is to deploy green power. In the past, only 1 to 2% of operator sites deployed green power. In remote sites, the traditional energy solution is expensive. For example, in Tibet and Qinghai of China, the cost of introducing grid power is high. Operators prefer to deploy PVs on these sites to reduce the power consumption costs. However, in the future, operators will deploy green power extensively. The energy crisis has led to energy shortages, with many operators in Europe facing sharp increases in electricity prices and energy access becoming difficult and unstable. Therefore, operators prefer to deploy PVs on sites to realize independent energy supply. As green power is deployed in more and more sites, secure and reliable operation of PV modules becomes important. Relevant standards organizations are developing the security and reliability standards required for developing PVs on communication sites. To build a self-sufficient, safe, and profitable green power system, you need to pay attention to a few points. First, how to achieve lower investment in business returns. The PV solution used on the operator's side is mainly the low-voltage parallel connection solution. With the development of utility PV and residential PV, high-voltage and serial connection technology have been popularized. Then this technology is also applied to operator communication sites. The high-voltage serial connection solution greatly reduces cables and engineering costs and helps operators deploy green power at a lower cost. 2. Greater benefits. Towers are usually built at operator sites. The towers create shades on PV modules in different time periods, reducing PV yield. Currently, operators add optimizers when deploying PV modules at sites to avoid shading and increase the yield. Third, secure and reliable operation is important for sites where a large number of PV modules are deployed. Operators pay close attention to PV module security detection technology such as arc detection and AFCI. As I mentioned, one trend for operators as energy producers is to deploy more green power. Operators as energy producers have another trend of transitioning from power backup to power backup plus energy storage. As we know, operators deploy a large number of batteries in communication sites to ensure the power supply of communication devices in case of grid power failure. Operators have invested heavily in batteries. However, in countries with good grid power, batteries may run for only 10 minutes in a year to ensure secure and reliable power supply. This is a huge waste. In the future, operators hope to use site energy storage to participate in more services and gain benefits. From saving money to making money. For example, operators are using site energy storage to participate in power services. To use site energy storage and participate in power services, operators must have the following 3 features. The first feature is simple. We know that operators have a large number of sites and different scenarios. Traditional batteries need to be scheduled by the power supply. However, operators have many power supplies of different specifications from different manufacturers on their sites. If the battery and power supply at each site need to be adapted, the deployment will be slow and difficult. We need a solution of decoupling of site batteries from power supply. That way, the deployment will be quick. The second feature is smart, which refers to massive, fast, and accurate scheduling. First, massive scheduling. It is meaningless for the energy storage of a single operator site to participate in power services. We need 10,000 or 30,000 sites to form a resource pool and have huge responsiveness to meet power service requirements. Second, fast scheduling. Different power services such as frequency regulation and peak shaving require different response speeds. Our solution has many algorithms to meet the requirements of different power services. Third, accurate scheduling. For example, if the power service requires a capacity of 1 megawatt-hour, the site energy storage system must provide a capacity of 1 megawatt-hour. This requires very high detection precision of a battery SOC and SOH. The third feature is converged. There are many types of power services such as frequency regulation and peak shaving and TOU. We hope to use a system to help operators realize different service evolutions so as to reduce operators' investment costs and enable them to participate in more power services to obtain greater benefits. Operators, as energy producers, have another important change of transitioning from telecom site to shared site. In the past, communication stations only supply power to communications devices. Currently, operators hope to use site capabilities to support multi-service development and gain more benefits. For example, China Tower adopts the one body and two wing strategy. The site power supply system not only provides power for one body services, but also provides power for two wing services, such as energy management and intelligence services. Second, power supply devices in Africa and other regions not only supply power to main equipment at sites, but also supply power to surrounding residents to gain more benefits. With the diversification of site power supply services, power supply technologies are developing from AC-DC power supply to multi-mode power supply. In addition to the traditional grid power and genset access, the site power must also support PV and wind power access. In addition to the 48-volt power supply for traditional communication equipment, the site power output must also support 12-volt, 24-volt DC, or even 220-volt AC to meet the requirements of different loads. Smart collaboration is also a technology trend, such as collaboration with power grid to participate in VPP services, collaboration with main equipment, that is, bit and watt synergy, to achieve efficient power consumption, collaboration with the smart meter to manage power supply to the surrounding residents. Just now I talked about the trend of operators as energy producers. Now let me talk about the trend of operators as energy consumers. First, operators, low carbon site construction. In the past, operators focused on the efficiency of site power supply devices. They moved sites from indoors to outdoors and removed air conditioners to improve equipment efficiency. Now operators' low-carbon construction has transitioned from extensive to systematic and standardized approaches. First, standards. The ITU has released the NCIE, the Network Carbon Emission Intensity Index. Operators can use NCIE to evaluate the network carbon emission and decide whether to optimize their network carbon emissions. Second, solutions. In addition to traditional methods such as removing air conditioners, operators can now deploy green power such as PV and wind power and remove gensets to save energy and reduce carbon emissions. Third, management. In addition to traditional power and environment management, operators also need to manage carbon emissions and energy efficiency. They can manage, control, and optimize network carbon emissions. Let me share with you a few examples. First, all-scenario PV deployment. In the past, only 1 to 2% of the sites were deployed with green power. Currently, operators perform all-scenario PV deployment in sites, equipment rooms, and data centers to save energy and reduce carbon emissions. Second, there are many gensets in Africa and Middle East sites. Operators use solar hybrid, grid hybrid, and diesel hybrid solutions to remove gensets or reduce the running time of gensets to save energy and reduce emissions. Third, deploy the network management system. Traditional power and environment management is only O&M management. Now operators are deploying intelligent network management systems. In addition to the traditional power and environment management, operators focus on the network-wide carbon emission management and visualize, manage, and optimize the carbon emission of the entire site. Operators as energy consumers have an obvious trend of simple sites. We know that the operator's network is getting thicker and the operator's revenue growth does not meet the expectation. Therefore, the operator pursues simple sites. What is simple is to build a network with simple architecture, high quality, low cost, and good experience. First, architecture. Before 2023, the site form changed mainly from rooms to cabinets. In the future, the site will change from cabinets to poles, that is the blade sites, to improve energy efficiency and reduce electricity costs. Second, quality. In the past, operators pursued less maintenance of site power supply equipment. In the future, operators will require long service life and maintenance-free for site power supply devices. For example, blade power supplies and blade batteries will be maintenance-free for 5 to 10 years, and the maintenance cost will become zero. Third, cost. In the past, operators pursued less cost of components. In the future, operators will pursue the lowest end-to-end cost, from site deployment to O&M. Fourth, experience. In the past, operators' requirement for site power supply equipment was to ensure no site power failure. Now operators also require high energy efficiency and low carbon emissions for site power supply equipment. As energy consumers, the next obvious change for operators is smart sites. As we know, operators' power supply equipment has a simple power and environment system. But in the future, the power supply equipment of communication sites will evolve from functional to intelligent sites, and comprehensive intelligent covering generation, conversion, storage, distribution, consumption management will be implemented. First generation, common PV modules equipped with optimizers will become IPV modules. It can achieve higher yield and safety. Second, conversion, from ordinary power supply to intelligent power supply. A lot of features are used to improve site energy efficiency. Third, storage, from lead-acid batteries to ordinary lithium batteries to intelligent lithium batteries. The hybrid use enables the hybrid use of old and new batteries to reduce the battery investment. On distribution, the traditional circuit breaker is changed to the intelligent circuit breaker, helping operators implement precise power distribution and reduce energy consumption. On consumption, the power supply and main device can be collaborated. The traffic volume of the main device can be associated with the power supply to achieve refined power consumption and reduce site energy efficiency. On management, the traditional power and environment management is changed to the intelligent NMS. In addition to simple O&M, energy efficiency management and carbon emission management can also be implemented. Smart sites help save energy and reduce carbon emissions and gain greater benefits. I've just talked about the trends of operators as energy producers and consumers. Behind these trends, many key technologies are required. What are the trends in key technologies? First, generation grid load storage synergy. In the past, the power supply devices at operator sites were isolated nodes, which could not collaborate with each other. For example, the power supply and power grid are not collaborated, the power supply and the main equipment are not collaborated. There's only the flow of electricity between them and there's no information exchange. This causes the low energy efficiency, high costs, and high carbon emissions of such site power supply equipment. In the future, site power supply equipment will achieve end-to-end generation grid load storage synergy, helping operators save energy and reduce carbon emission. For example, the synergy between the power grid and energy storage can realize VPP and the PV plus energy storage synergy. For example, the collaboration between the power grid and the power supply can achieve peak shaving in 5G construction without the need to reconstruct the grid, which can reduce the investment in 5G construction. For example, the collaboration of power supply and load can realize bits managing watts, reducing the power consumption cost of main equipment. These collaborations require the support of underlying technologies. On one hand, power electronics technologies such as components, algorithms, energy storage, and cooling, and on the other hand, digital technologies such as sensing, connectivity, cloud, and AI. Through these technologies, power flows and information flows will interact, bringing higher energy efficiency, lower costs, and lower carbon emissions to customers. Another key power supply technology for operator sites is the diversified battery technologies. In terms of materials, in the past 10 years, operators generally use lead-acid batteries at sites. In recent years, more and more operators are choosing lithium batteries instead of lead-acid batteries. In the future, operators may also choose sodium batteries because of the better availability of raw materials and lower costs. In terms of application, sodium batteries are safer, better in low-temperature scenarios, and have a high charging rate. In terms of technology, lead-acid batteries and common lithium batteries have only basic parameter management such as SOC and SOH. In the future, battery technologies will be used in more and more application scenarios, and more intelligent technologies are required such as hybrid use, IoT, intelligent anti-theft, intelligent voltage boost, and VPP. The last trend is the security and reliability of the power supply system of operators. In the past, operators' requirements for the site power supply system were to ensure no power failure and the safety of communication equipment. In the future, operators will attach great importance to ensuring energy cybersecurity in addition to no power failure. There are 4 aspects. First, device security, including component security, usage security, and maintenance security. Second, network security, including architecture security, data security, and defense against attacks. Third, security authentication. Over the past few years, the EU, US, and China have issued safety laws and regulations. To obtain market access, suppliers and operators must obtain certifications of the local market. Fourth, trustworthy processes and results. In addition to obtaining certification, operators and governments review the security and trustworthiness of suppliers' products and solutions during development. Meanwhile, the EU, US, and China have released data sovereignty rules, which are important for vulnerability management and privacy protection. Device security, network security, security authentication, and trustworthy processes and results will ensure the security of operators' energy network, ensure no power failure, confidentiality and traceability, and defense against attacks to build secure and trusted results. We have released the top 10 trends of Site Power 2024. In the past, Huawei Site Power has shipped millions of sets of products and solutions worldwide. With 900 million kilowatt-hour of green power generated, 33.89 billion kilowatt-hour of electricity conserved, 16.2 million tons of carbon emission reduced, and 21.99 million trees equivalent environmental benefit achieved. We hope that Huawei Site Power will work with you to build a green, better future. Thank you. Thank you, Mr. Li Xiaolong, for your wonderful sharing. Huawei Site Power will continuously activate the potential of sites and promote low-carbon development. Dear guests, the top 10 trends of Site Power Launch 2024 has been successfully concluded. Thank you for your participation. To download the white paper, please scan the QR code.